Okay, example 3. Two sides of a triangle have lengths of 15 meters and 20 meters. The angle between them is increasing at a rate of pi on 90 radians per second. How fast is the length of the third side changing when, at the instant, the angle between the sides is pi on 3? Okay, let's just think about this for a second. You don't need to write this out. If I am looking at what's happening here, I have two sides to a triangle, and there's an angle between them. And what's happening is that the angle between them is increasing. The angle between them is increasing at a rate. So this guy is moving and he's increasing. So we have to be careful here to make an assumption. We can't use a right triangle like we had in the previous two examples, because sure, at one exact instant we might have ourselves a right triangle, but this angle could eventually go past and become an obtuse angle. So that means we are not dealing with a right triangle. Okay, so let's look at this. We have two sides. Okay, one of them is 15 and one of them is 20. And those are constants. They aren't changing, but the angle between them is changing. The rate at which the angle between them is increasing at a rate of pi on 90. So I know theta dt is equal to pi on 90 radians per second. That's what I know. And I also know that I cannot assume this to be a right triangle. So there is some third side across that I have said let that third side be x. So theta is the angle between the two. And notice how I gave my restriction for that angle to be between 0 and pi. Okay, so he can go from anywhere from 0 to 180 degrees. He hit 180 degrees and we no longer have a triangle. Okay. All right, what else do we know? We are trying to find how fast the length of the third side is changing. So what is dx dt at the instant when theta is pi on 3? So that is a changing quantity. 15 and 20 are constants, but the angle is changing. Okay, so if this isn't SOHCAHTOA, then I have to think about another way to relate my angle and my third side. Now, we have to flash back all the way to Math 20, and this is actually going to require us to use the cosine law, which says a squared is equal to b squared plus c squared minus 2bc cos a. Okay, so that is when you have your triangle, x would be my equivalent of a, and then 15 and 20 are my b and c, and then you have these big a, b, and c's on the outside. Okay, so we're now going to fill in our pieces. Now we can put in 15 and 20 for b and c because they are constants. Okay, they are not changing. So a is x. So x squared is equal to 15 squared plus 20 squared minus 2 times 15 times 20 cos of theta. All right, let's tidy this up. We have x squared is equal to 15 squared plus 20 squared, which is 625, minus 2 times 15 times 20, which is 600 cos theta. So now I have my function that I need to take the derivative with respect to time. So the derivative of x is 2x dx dt is equal to 625 minus 600. Back up. My bad. 625. Just got into writing it out again. The derivative of 625 is 0. The derivative of negative 600 cos theta. So negative 600. And then the derivative of cos is negative sine theta d theta dt. Whew, good catch. That would be a disaster. All right, so let's see. Can we tidy this up a little bit? Let's just divide that 2x to the other side because it's easy, and those two negatives make a positive. So we have 600 sine theta d theta dt all divided by 2x. So that's what I now need to see if I have enough information to fill in all my pieces. Okay, so dx dt is equal to 600 sine theta, and theta at the instant of pi on 3. So I'm putting in pi on 3. And we know d theta dt is pi on 90, all divided by 2 times some x value. So we have to go back to that triangle, which I'm going to just redraw here, and think about how we could find x. So we know 15 and 20 are our two sides, and now we're looking at the instant that theta is pi on 3. So we're going to go back to our cosine law that we tidied up as x squared is equal to 625 minus 600 cos theta. That's where we're going to find our x value at the instant that theta is pi on 3. So x squared is equal to 625 minus 600 cos of pi on 3. So this is 625 minus 600 times at angle pi on 3, cos is 1/2, nice and easy. So 625 minus half of 600 minus 300 is 325. And so to find the x value, I want to take the square root of this, and that tidies up to 5 square root 13. So now I know that this value on the denominator needed to be 5 root 13. And now the calculus and everything is done. The last part is to tidy up our answer. So we have that dx dt is equal to 600. And then we had sine of pi on 3. Sine of pi on 3 is root 3 on 2, multiplied by pi on 90. And then that was all divided by 2 times 5 root 13. So 10 root 13. And I'm going to try and tidy this up. Feel free to pause and see if you can beat me to the finish on the cleaning up here. So let's just work with the numerator. 2 times 90 is 180. 600 on 180 is 10 thirds. So we have 10 pi on 3 root 3. We still have the root 3. Divided by 10 root 13, or multiplied by 1 on the reciprocal of that. Okay, and then I can see that my 10s can cancel. This is really not pretty at all to work in exact values. So what do we have? We have pi root 3 on 3 root 13. And of course, we're now going to rationalize that denominator. Okay, so now we have 3 times 13 is 39. So I have a square root of 39, which is not going to reduce, all on 39 on the bottom. And the units on that should be meters per second, dx dt. And then we would write our lovely little statement that would say, therefore, the third side is increasing at a rate of pi root 39 on 39 meters per second when theta equals pi on 3. All right, so that's the end of the related rates examples. Example 4 is going to get into our chapter 4 max-min questions, and I will see you back for video number 4 to see this example.